Space, in both concept and reality, is endlessly vast and mysterious. We peer into the inky blackness hoping to find someone peering back, to find entities similar to ourselves, and provide an answer to the question, are we alone in the universe? The most likely spots to find this answer are out there scattered among the cosmos, waiting to be found. These carry the title of exoplanets. Hello, and welcome. My name is Micah, and today I'll be talking about exoplanets. I obviously can't go on about them without first explaining what they are, so let's start off with that. So Oxford defines an exoplanet as a planet that orbits a star outside the solar system, which is about as simple as it gets. Is it a planet? Is it outside of our solar system? Does it happen to orbit a star that isn't the sun? If all answers are yes, then you've got yourself an exoplanet. Despite the straightforward definition, actually observing them, calculating their properties, and finding one that checks all the required boxes for life is much more complicated than it seems. I can already hear you thinking, so how were they discovered? How have we found details about them? How do we know if a planet can sustain life? Well, the astronomers of today employ an ancient technique, looking up and doing math. No, really, the only difference is that nowadays they use bigger telescopes and fancier computers. For my hypothesis, I believe that astronomers of the past paved the way, and with help from increasingly advanced technology, today's professionals can collect data on exoplanets more accurately and efficiently than ever before. However, despite being able to locate exoplanets and calculate basic details, determining if they meet the basic requirements for life is still a daunting task. Now to stress test the accuracy of my hypothesis, I'll be presenting the research I've gathered from various scientific articles and resources. I did my best to dive in headfirst, locating the original sources of information and gathering everything I could find. All properly cited, of course, on screen and in the description. So let's start by taking it all the way back to the discovery of the first exoplanet orbiting a star like our very own sun. These gentlemen are Michael Mayer and Didier Queloz, and they are credited with the discovery of an extraordinary exosolar planet in 1995. They were able to determine that there was a planet orbiting the star 51 Pegasi, and named it 51 Pegasi b. It's a Jupiter-sized gas giant that is much closer to its star than our own Jupiter, with a very small orbital radius of just 0.05 AU, which means it can complete a full orbit around its star in just 4.2 days. Mayer and Queloz utilized radial-velocity observations obtained with the LED spectrometer and a telescope at an observatory in France. Basically, while observing the star 51 Pegasi for several years, they noticed that it moved as if it were being pulled by another force. This outside force was a planet. You see, when a star has objects orbiting around it, it won't remain completely stationary and will move ever so slightly in a small circle or ellipse in a response to the gravitational tug of the object. So, with the info they were able to collect, they were able to estimate a bunch of things, like its mass and its size. Even though Mayer and Queloz were able to calculate many things, they were unable to determine finer details like the planet's atmosphere, and also had a much more difficult time finding smaller rocky Earth-like planets in general. Pegasi b was just the start to the search for exoplanets that shared properties with our own. As time marched on, technology advanced at an exponential pace, leading to even more amazing discoveries. The most exciting being, of course, the one and only James Webb Space Telescope. In case you somehow haven't heard about this amazing piece of technology, here's a couple of quick facts. It orbits the sun rather than the Earth, carries many new innovations like a folding segmented mirror, and has tons of sensors and instruments. Being one of the newest space telescopes launching on December 25th, 2021, it was loaded with all of the bells and whistles many space organizations dream of. The telescope is equipped with many powerful sensors, including some of the ones on screen. Its main mission is to, quote, complement and extend the discoveries of the Hubble Space Telescope. With longer wavelength coverage and greatly improved sensitivity, the longer wavelengths enable Webb to look much closer to the beginning of time and to hunt for the unobserved formations of the first galaxies, as well as to look inside dust clouds where stars and planetary systems are forming today. This means that the James Webb Space Telescope is presently the most powerful resource we have in the search for life outside of our very own solar system. It's also potentially capable of confirming the theories surrounding the requirements to harbor life. Just 2 years after its launch, the first of the exoplanet discoveries by the James Webb Space Telescope was documented, labeled as planet LHS-47b. It was found by a research team led by Kevin Stevenson and Jacob Lustig Jaeger from Johns Hopkins University. The telescope only needed 2 transit observations to capture the planet and collect information about it. It almost exactly matches Earth in size. And what's even more remarkable about the discovery, shared by Didier, is, quote, the fact that it's also a small rocky planet, end quote. This is impressive because smaller, rockier planets were previously very hard to detect in comparison to larger gas giant planets, like Mayer and Queloz's Pegasi b. As Astrophysics Division Director at NASA, Mark Clampin puts it, quote, these first observational results from an Earth-sized rocky planet open the door to many future possibilities for studying rocky planet atmospheres with Webb, end quote, and also states that these discoveries are, quote, bringing us closer and closer to a new understanding of Earth-like worlds outside of our solar system, end quote. Yet another exciting aspect of this discovery is the fact that Webb is so far the only space telescope with the capability to recognize the atmospheres of Earth-sized exoplanets. While the atmospheric makeup of LHS 475b is yet to be confirmed, additional spectral observations may reveal its composition. Either way, LHS 475b's discovery is a great example of Webb's future contributions. There's still a lot that remains a mystery in the search for extraterrestrial life, but research on exoplanets only continues to grow. This information that I was able to gather is just scratching the surface on the mountains of data that already exists. To summarize, exoplanets are planets outside of our solar system, and my hypothesis that their detection has only become easier with the aid of time and technological advancements has been reinforced by the previous information. And, while detecting their atmospheres was previously near impossible, innovative technologies like the James Webb Space Telescope have made it more possible than ever before. I know this was very dense, but thank you so much for hanging in there, and I hope you learned something new. Thank you so much for watching. Last but not least, here are all of my wonderful sources. This video could not have been possible without them, so go check them all out. They're all also listed in the description below.